All right, we're solving absolute value equations today. Your first step when solving these equations is to isolate the absolute value on one side of the equal sign. That just means get rid of everything except for the stuff in the absolute value sign. So once you do that, you're going to set up two equations. You're going to set up one with a positive version of the answer and one with a negative version of the answer. Let me show you what I mean. So number one, we already have the absolute value symbols already by itself. Now, the absolute value of this equals positive 7. If I can get the inside of that to equal 7, then that's true because the absolute value of 7 equals 7. But if I can get it to equal negative 7, the absolute value of negative 7 is still 7. So that's why we set up two equations, because both of those would end up working to be true. So get the absolute value symbols by itself and then set up two equations. We're going to set up 5x plus 3 equals 7 and 5x plus 3 equals negative 7. We're just going to solve them both and then we're done. Now, they both have the same two steps. We're going to minus 3. Here we'd have 5x equals 4. Here we'd have 5x equals negative 10. And then we would divide both of those by 5. We're just going to leave our answers, if they don't divide evenly, just leave them as simplified fractions. So 4/5 over here, and here this comes out to negative 2. So you can list them separately. You could say 4/5 and negative 2, or you can list them as a set with those parentheses. And usually you list the smaller one first, negative 2, 4/5. I honestly don't care how you list them. If you want to just list them separately, that's cool too. So number 2, we've isolated the absolute value symbols. Great, so we'll set up two equations. 2x minus 3 equals 11, and 2x minus 3 equals negative 11. We'll add 3 to both of them. 2x equals 14, plus 3 over here. 2x equals negative 8. And then we'll divide both of those by 2. 14 divided by 2 is 7. And negative 8 divided by 2 is negative 4. If you wanted to list them as a set, negative 4 and 7. Now, both of these work in the original equation. If you put them in for x, like if we put in 7, 2 times 7 is 14 minus 3, absolute value, well, that's 11, and then the absolute value of 11 is 11. That's true. If I put in negative 4, 2 times negative 4 is negative 8. Negative 8 minus 3 is negative 11, and the absolute value of negative 11 is 11. They both work out to be true. Now, once you have, well, we'll get there when we get there. I have a special problem coming up. That's very exciting. All right, let's dial it up a bit. Now, a lot of these in class, I'm intending to go over one and then you try the other one. So we're going to try 3, and then I'd like you to pause the video, try out 4, check back in when you're done, and see how you do. We have it down to the absolute value symbols, so we'll set up two equations. X over 2 plus 1 equals 11, and x over 2 plus 1 equals negative 11. Just like always, it's the same steps for both of them. Minus 1. And then to cancel out that divided by 2, we would multiply 2 on both sides. So we get x equals 20, and x equals negative 24. Both of those work in the original equation. So again, why don't you try this one, pause it, and check back in, because I'm going to go over it pretty quickly now. And we're back. X over 5 plus 7 equals 13. X over 5 plus 7 equals negative 13. Minus 7. X over 5 equals 6. Minus 7. X over 5 equals negative 20. And then we would multiply the 5 x equals 30 times 5 here, x equals negative 100. Great. All right, let's see what else we got. I'm pretty sure we're going to have to dial it up here. So remember, we have to isolate the absolute value symbols first. We have to get it to where it's just the absolute value symbols before we set up our two equations. Otherwise, half of our answers will be wrong. One of them will work, but one of them won't. So here we have to get rid of that plus 6 before we set up our two equations. It's pretty easy to do, just minus 6. Absolute value of 2x equals 2. We have it down to the absolute value symbols, so now we'll set up our two equations. 2x could equal 2, or 2x could equal negative 2, and both would work out. So we'll divide by 2, x equals 1, we'll divide by 2, x equals negative 1. If you put either of these into the original problem, they both work. So again, why don't you pause here, try it out, but I'm going to go over it real quick. Minus 8 first, absolute value of 3x equals 9, and then we would set up two equations. 3x could equal positive 9, or 3x could equal negative 9, and it would work out. Divide by 3, x equals 3, divide by 3, x equals negative 3. You could list that as plus or minus 3 if you want, or you can just list it in parentheses like that, or just list them separately. It doesn't matter. All right, that was just getting us ready to go here. Here we go. Number 7, we're trying to isolate the absolute value symbols. I see a loose plus 25 there. I'm going to go ahead and subtract 25 from both sides. So we have 2 times the absolute value of x equals negative 2. Now that 2, a lot of people are going to want to distribute it. You can only distribute over parentheses, not absolute value signs. But we can cancel that out. It's 2 times that. So we can just divide both sides by 2. The absolute value of x equals negative 1. Now, pause here for a moment mentally. You don't need to pause the video. What number has an absolute value of negative 1? Nothing, right? Once you get it down to the absolute value symbols, it cannot equal a negative number. Because if I put in negative 1 there, the absolute value of negative 1 is 1. And if I put in positive 1, absolute value of positive 1 is 1. Absolute value cannot be negative. So once you get it down to absolute values equaling a negative number, you would say no solution. There's nothing you could put in for x to make this work out. Promise you. Hey, try this one out. It might be totally different. Give it a pause, try it out. Minus 9. Then we would divide by the 3. An absolute value cannot equal a negative number, so we'd say no solution again. I should have split those up. Oh my gosh, I'm just silly like that. All right, here we go. Oh, wow! Now look, we're trying to isolate this absolute value symbol. This right here, we're trying to get that by itself. It's just like we're doing this. And I guarantee if I showed you this equation, everyone would know what to do. But here you're isolating the y. All I did was change that out, right? It's the same steps. We're going to get rid of the negative 5 somehow. We're going to get rid of the plus 1 somehow. Same thing. So first we'll get rid of the plus 1 by subtracting 1. We have negative 5 times the absolute value of 7x plus 2 equals negative 25. Now I know someone's going to get to that point and they're going to be like,
Mr. Plank, you just said that absolute value cannot equal a negative number.
that's true, but we haven't gotten it down to just the absolute value symbols. We got to get rid of that negative 5 in front. It's being multiplied. We're going to have to divide it. Oh, snap. Negative 25 divided by negative 5 is positive 5. Ooh, sorry, it worked out positive. Now once we have our absolute value symbols all alone, it equals a positive number. That's cool. Now we set up our two equations. 7x plus 2 equals 5. And 7x plus 2 equals negative 5. And we're back, baby. Subtract the 2. 7x equals 3. Subtract 2 over here. 7x equals negative 7. And then we just have to divide those 7s. We get 3/7 here. This comes out to negative 1. If we were to put those in the brackets, a solution set, you would put your smaller number first, negative 1, and then your 3/7. Those are as tough as they could possibly get. So again, try it out. See how you do. Pause it, try it, check back in. So I would add the 5 first. Eight, and then we would divide that 4 out in front. Absolute value of 2x minus 1 equals 7, and then we would go ahead and set up our two equations. 2x minus 1 equals 7, 2x minus 1 equals negative 7. All right, we'll add 1. 2x equals 8. 2x equals negative 6, and then we'll divide them by the 2. X equals 4, and x equals negative 3. If we list them as a solution set, the negative 3 would go first. Cool. All right, and then of course, we just gotta go, we gotta go top dog on this one. You ready? All right. Ooh, two absolute value signs. So what I've been saying all along is get it to where it's an absolute value sign on one side of the equation, and then set up two equations, one with a positive version of the answer and one with a negative version of the answer. So let me show you how that would play out on these type of problems. And we're just going to do both of these together. So we drop the symbols over here. X minus 3 equals a positive version of the answer. It wouldn't change. It would just be 8 minus x. No big deal. Just drop the symbols. The other equation, x minus 3, would equal a negative version of the answer. Here's how we're going to write that. Negative, parentheses, 8 minus x. That's it. That's the big change there. Just put negative, parentheses, and then whatever you had over there. So if we were to solve these now, let's see here, we could add an x to both sides. We'd have 2x minus 3 equals 8. I'm going to finish this one up and then we'll hop over to that one. Plus 3, 2x equals 11, and then we would divide by 2, x equals 11 halves. Cool. Here, if we distribute that negative, it would make it negative 8 and then plus x. So now if we subtract an x from both sides, we're just left with negative 3 equals negative 8. There are no more x's. Does negative 3 equal negative 8? No. So there's nothing over here. This doesn't work out. It's all good. So we just ended up with one solution, and that's fine. It's okay. Maybe it'll work out to 2, maybe it'll just work out to 1, maybe it'll be no solution. Who knows? So this one, we've isolated the absolute value symbols. So we'll set up two equations, one with a positive version of the answer, one with a negative version of the answer. So a positive version of the answer, you just drop the signs. The other one, 3x plus 2 will equal a negative version of the answer. So negative, parentheses, 5x minus 8. Cool. I'm going to finish up this first equation before I move on to the second one. So we'll subtract 3x's from both sides. 2 equals 2x minus 8. You know we would add the 8. 10 equals 2x, and then we would divide it by 2. 5 equals x. Cool. Over here, if we distribute that negative, that would make it negative 5x plus 8. And then we would get the x's on the same side by adding 5x to both sides. 8x plus 2 equals 8. And then you're probably thinking minus 2. 8x equals 6. And then we'll go ahead and divide by 8. Now 6/8 would simplify to 3/4. So we have 3/4 is smaller than 5. If you were putting this one into a solution set, it would just have that one solution, 11/2. I really stink at drawing those parentheses. That's why I don't oft like doing it. So those are challenging problems, but you did it.